Hello everyone, welcome to Statistical Foundation for Big Data Analysis. In last two talks, we generally talked about what big data is and what are the challenges, and basically we talked about how big data involves two aspects, big data processing and big data analysis, and then we talked about statistics as a statistics. We talked about that statistics serves as the foundation for big data analysis. Statistics is the foundation science that provides foundation for data analysis in general and big data analysis in particular. We talked about various data types and we mentioned how classical multivariate statistics remains extremely relevant for analyzing big data. So today what we will do, we will just provide you a general overview of the process of statistics itself. So data science process involves the following trajectory. You have reality, this earth is the reality. I, by the way, got this picture from Wikipedia. First, what happens at, so what we really want to do with statistics or data science, we want to understand the reality and provide certain tools that is useful for day to day life. So raw data is collected, then data is processed for analysis. Before analyzing, you have to store it, clean it, transfer it into, transform it into analyzable mathematical form. So data is processed, and then what happens is that, like, data sometimes involves certain junk, some noise, missing data, certain wrong data. So then you have to clean that data. So once the data is cleaned, that clean data set goes to something called exploratory data analysis. So take a step back and think. Data is collected from world. This raw data can come in various format. Often it's questionnaire, which will involve certain numbers, of course. Just try to imagine census data. It may involve number, but then it will also have certain question whether you are married or not, which city you live, and then somehow this questionnaire, which involves some numbers and some text and everything, it has to transfer it into some mathematical form. Last class we have seen that even structured data like graphs or matrices can be converted into vectors. So eventually, I am not saying that all data analysis is in the vector form, but eventually this data which potentially involves certain non-numerical things will be transferred into something mathematical, numerical. Sometimes certain things will be categorical, which essentially means that, let's say we are talking about whether somebody is married or not, that question may be transferred into ones and zeros, where one, let's say one indicates the person is married, 0 indicates the person is unmarried. This is different from height being 1 point something. There is a natural ordering between a 6 feet person and a 5 feet person, but between married and unmarried there is no such ordering. So categorical data is, you can as well write it in forms of A and B, like, or M and N, married, M and U, married and non-married, married and unmarried. But even there, what happens is that, like, you eventually, with tacit understanding that it essentially 1 means M and 0 means U, you convert everything in certain numerical format with the understanding certain points are not numerical. This is your mathematical data set. This, through processing, you store somewhere in this format, then you clean the data set. Wherever there is junk, you just throw that out. Wherever there is some wrong data, you just correct it. Wherever there is some missing data, you inquire and fill the gaps, etc. You do various process. Finally, the data is ready for analysis. Next, what you do is exploratory data analysis. This is extremely important. This is the visualization. If you are simply thinking about a vector, you just plot it. You are thinking about, tuples, data as numerical tuples, you simply plot it. This plot itself sometimes indicates many things, like it immediately, if you plot a data set, you will see certain clusters. So, that already indicates why there are clusters. This has to be analyzed. So, clusters already indicates that these are forming groups, that is already certain information. But then there are shapes of these clusters. Also, when you plot the data, one of the most classical thing to do is that, like, you find the center of the data and how spread out the data is from center. Now, simply locating the center and the spread already tells a huge amount of, gives you a huge amount of information about data. Now, once you look at the center and the spread, what may happen is that, like, few data points may just lie very far from the center, like one or two, there is this data cloud and one or two things are far away from the data cloud. They indicate certain outliers. So, these things, which are the outlier points and which center, which is like close to center in a homogeneous way, these things are visualized in exploratory data analysis. Now, using after this exploratory data analysis, you go for the models and algorithms. Sometimes you do not do the exploratory data analysis, you directly go for modeling, data modeling, and finding algorithms to create certain product based on the data. But this is the hard analysis part, building models and algorithm based on data. Algorithms can just simply mean creating a formula that is a compact form of a relation. It can potentially give you, say, your data has certain dependent variables and independent variables. It may be a complex, that from that data you may come up with a complex, certain series of complex steps where the dependent variables follow those steps to come up, tell you certain values about the, sorry, the independent variables follow those complex steps to come up with a outcome for the dependent variable. This is, by the way, done in the one of the most widely used and one of the most advanced data analysis tool called neural network. You come up with an algorithm, you feed the data in a neural network, it comes up with an algorithm for future use. Now, whether you do exploratory data analysis and then modeling an algorithm, or just directly you do the modeling an algorithm, you do one of the two things. You just simply publish your result in forms of some report, communicate the outcome and make a decision based on that, or using that you create certain tools, database tools. For example, you just, all of us are using grammar corrector in Gmail or the autocorrect in WhatsApp. These are the database product and they become commercial product in the reality, or you just use this report, this modeling, whatever is the outcome, make certain database decision. This is the whole scheme of data science. Now, a definition for data analysis was given by statistician John Tukey. So, he defines it as procedures for analyzing data, techniques for interpreting the results of sub procedures, ways of planning the gathering of data to make the analysis easier, more precise and more accurate, and all the machinery and results of statistics which apply to analyzing data. In simple terms, statistics or data analysis is the science of learning from data. So, now we are getting into the domain of classical statistics. We really need to do classical statistics for some time to introduce you to the techniques that are extremely relevant for big data analysis. So, statistics essentially is inferring about a population based on a sample. A population is the set of all measurements of interest to the sample collector, and a sample or data is a subset of measurement collected from the population. So, scheme of scientific research goes in the following way. You formulate the research. So, this is, by the way, has taken from this book, Introduction to Statistical Methods and Data Analysis by Ott and Longnecker. So, generally scientific research comes in the goes in the following follows the following steps. You first of all you start with a research goal, and then you design the study. For the study you formulate the sample size you need for that study, what are the variables that you want to study, experimental units are needed, sampling mechanism, formulate research goals, and then you design the study, then you collect data, then you draw inference from data, you make decision based on that, and then formulate new research goals, and then you again come to the design of study. So, you first formulate research goals, then based on that research goal you design a study. Science is based on experiment. You want to study something, for that you do some experiment. For experiments you need to have precise formulation of certain variables on which you will experiment, and then based on that you actually do the experiment. You just collect the data, test it, and you also have to decide how big data you need. That is the sample size. You have to fix the units of the experiment, and you finally actually do the experiment. After you have done the experiment, you collect data again, the outcomes of the experiment data of which is the outcome of the experiment. Then based on that you draw inference, come up with some decision based on that, and that comes with basically gives you the conclusion of the experiment. Now from that conclusion of the experiment, that gives you new research goals, and finally you come back to designing of the study for the new research goal. This is how the scientific scheme of scientific research keeps going. So in the whole process, fundamentally you have this something, the ambit of all possible measurement, ambit of unknown, which is called the population. You are trying to understand that based on a sample collected, which is the actual measurements you have done. So this inferring about all possible measurements based on some selected measurement is the foundation of statistics. So statistical method is essentially you take the set of all measurement, the population, and set of measurements collected from the population, the sample. You want to decide about the population based on the sample. That is your statistical method. So data collection can be done in various methods, surveys and questionnaires. You can do one-on-one interview, you can systematically simply watch and observe, you can study focus groups, you can actually do experiments, you can also get into archive and look documents and record. All these are used to used for data collection method. Here is a scheme for data collection. So once data is collected, you do data summary and visualization. As I was saying, this is basically this exploratory data analysis step. So you look for, once you have done, you have taken bunch of measurements, you look for example, one of the most important thing is mode, which measurement is coming most often. You look for middle point, this is called median or the middle point. You have various measurements, you are looking for the middle point. You look for mean or arithmetic, the average values of all the outcomes. Then you look for the spread. All these things, this mode, median, mean, they are sort of are called central values. The most important value or the central value or the average value, they are looking for the center of the data. This is one thing you want to do, as I was saying at the beginning when we were chatting about exploratory data analysis. In exploratory data analysis, it is extremely important for first look for the center, and then once center is located, you look for spread, how spread out from the center it is. So that is one extremely important measure of center is the variance. So the arithmetic mean, if your values, the measured values of the measurements are y1, y2, yn, the mean is just you take their sum and divide by the number of measurements, the n, and the variance is defined as the average distance of average squared distance of every data point from the center. This is 1 over n summation yi minus y bar whole square. Then data visualization is done using various bar diagrams and charts. These are some of the important diagrams and charts: pie chart, bar chart, histograms, Gantt chart, box and whisker plot, waterfall chart. These are all used for depending on the situation you are studying. After you have done exploratory data analysis, you actually go for this hard data analysis, modeling of an algorithm building that we were talking. You actually try to formally infer about the population central values. You try to you infer about central values of two different population. You want to compare whether given two different population their centers are same or they are different. If they are different, whether one is bigger than the other, and so on, like how far they are, etc. You infer about population variation, population variances, that is how spread out the populations are. We were discussing about categorical data, where like the values are not really numbers, in a sense they are not, one is not bigger than the other, but they are just categories like married, unmarried, or let us say you are talking about people of India, you may categorize them in terms of their mother tongue or the state they are born. So, these are all categorical data. So, that needs a special analysis, like how do you analyze categorical data. Sometimes what happens, that data, as we are saying, the data has multiple features. You want to find relation between various features, and generally linear relation is quite a useful thing. So, that is called linear regression. There is also something called logistic regression that is used for classification of data. These are also something people study quite a lot, and ultimately these are basically studying the correlation, the relation between various features. Then for multivariate setup, there is this multivariate version of regression which is called multiple regression, and generalized linear models that are also quite important. And finally, you have to understand various variabilities, and there is something called covariance. Variance is the spread of one point, and covariance is relative spread when you are taking multiple features. So, this variance and covariance is also something one tries to understand in case of data analysis. So, let us get back little bit. So, we are discussing what happens in case of we are discussing this overview of statistical method. In the data science process, the most key aspect is to analyze data to come up with inference. So, basically based on data you are trying to learn about the unknown. This unknown is called population. Formally we visualize unknown as the set of all measurements of interest to the sample collector or the data collector. A sample is a subset of measurement which actually has been observed. So, based on what has been observed, you want to predict about the population. So, for the scientific research, this process is repeatedly studied. So, this is almost statistics, this data analysis provides almost the grammar of scientific research. So, this is what we are trying to aim at, like set of all measurements. We want to talk about that based on set of some measurements that actually has been done. You collect the data, that is you make the measurements using certain processes, surveys or questionnaire, interviews, observation, certain targeted focus groups, experiments, archives and documents. Then, so this is the diagram. So, these are the processes in sometimes are followed in real life data analysis. Then you go to the visualization part or the exploratory data analysis part. So, there you try to first locate the center and the spread of the data. Center can be done using various central tendencies like mean, median, mode, etc. And for the spread you can use variance, and often sometimes square root of the variance is also used, which is called standard deviation. And then you use various bar diagrams and charts and histograms for the visualization. Many inferences can automatically, many research directions can be automatically found by visualization. For example, if the data is already clustered in several groups, you can try to identify the clusters and what features of the data. If it's let us say we are talking about a vector format multivariate data, these clusterings are based on what relation between the features, that also gives you a direction. Then you come to this hard data analysis part, where you try to actually mathematically derive inferences about population central values and central values of different populations and population variabilities. You try to get relation between various features that creates data with focus on linear relation is something quite important, and that leads to eventually something called generalized linear models. There is something also called logistic regression, which is important for classifying data instead of finding relation between various variables. So, essentially relation between various variables in one form or other is also studied. And finally, there is something called analysis of variance and covariance, ANOVA and ANCOVA, which also is important in study of variability. So, this is how the overall statistical process goes on. Something unknown, unknowable perhaps. Just to give you an example, when you are, for example, you have a coin, you want to toss a coin. You want to know what is the head probability of the coin. So, you have a coin, you want to know about the head probability. How do you know the head probability? I mean, we sort of start by assuming there is something intrinsic called head probability of the coin. Well, this is true, there is something intrinsic which can be considered as head probability of a coin. What is that? So, in science, there you want to claim something, there has to be an experimental validation. Always whenever I introduce this, I give this example. When you drop a ball, you say the time covered, the distance covered is proportional to square of time, s equal to ut square, s equal to some constant time t square. It is not t cube, it is not t to the power 1/5, it is t square. This can be experimentally validated. You can drop a ball and you can measure repeatedly and you can see the pattern, like it is essentially the t square is a natural law, it is a law of nature. Similarly, if you keep tossing a coin, say toss the coin n times and take the proportion of heads, call it Pn, let us say count the number of heads divided by n, call it Pn. Now, if you keep doing it for various n, as n goes to infinity, this Pn converges to a value. So, if you toss a coin large number of times, you get a kind of, you can see a pattern that, like let us say if you do 1000 or 10,000, you will see you keep getting 60% or 70% of the time heads, or 30% or 70% or 50% of the time you keep getting head, and if you keep doing larger and larger number of time, this number stabilizes. So, it almost appears like that is a fixed number. Eventually, if you do it for a large number of time, it becomes a fixed number. So, this fixed number, it almost appears as something intrinsic to the coin. That is called the head probability. So, we are counting the portion of heads, not tails. You can 1 minus the head probability will be the tail probability. This number is something we want to understand. But now, of course, these are approximate limit things. You really cannot expect, you want a method of inferring about head probability. You cannot keep just doing it for n going to infinity. I mean, it only says it will converge. It does not say that whether it will converge in 1000 step or million step, but it only theoretically one can show that it converges. So, it is impossible to actually do that so many times and actually find the head probability that way. So, how do you do it? How do you infer about it? This is where this process of statistics comes. We want to toss the coin certain number of times, feasible number of time, and based on these tosses, we want to have an educated guess about the head probability. This is where what statistics does. Now, let us say you toss the coin 10 times, you get 7 tosses, 7 heads. An educated guess is that like 7 divided by 10, that is your head probability. Now, of course, even before we do some theory, you can kind of guess that more tosses you do, better your prediction will be. But here is the catch. For any number n, we can actually guess how good our prediction is. So, this type of science is what we do in statistics. So, in a schematic form, this is something I always discuss. Statistics is basically you collect data based on linear algebra and calculus, you come up with some prediction rule. You have data collected from some population, you do some mathematics on that, that generally involves certain linear algebra techniques, that is equation solving and equation manipulation. You collect data because almost always data are vectors, you will get vector algebra, which is linear algebra, linear equations, and for even regression, etc. So the point is why linear? If you in simple calculus format, tangents to curves give fairly good approximation to curves locally. So linear approximations just work in real life. So this is why, and also these are vector data. So for formulating vectors in vectors as points in n-dimensional Euclidean space, adding two vectors and forming equations based on asking for various transformations from Rn to Rn which are linear is quite useful here. So linear algebra is used quite heavily, and then finally when you want to predict something based on the data, what happens is that you kind of go for certain optimization technique. You look for some function which you look for certain function with some unknown parameter which is optimized by these data points for certain values, and that gives you the functional form. So this is where the optimization or calculus is used. So simple term, you have data, you apply linear algebra and calculus, you come up with prediction rule. This is the schematic representation of statistics. Now for big data, what happens is that the setup, like machine learning has become a common word essentially for analyzing, applying statistical analysis to the framework where classical linear algebra and optimization algorithms are not just enough. In a sense, they are not enough in a sense. Just to give you a simple example, perhaps the optimization techniques involved applied on 1000 cross 1000 by 1000 matrix can be handled by classical softwares. But suppose you want to apply the same optimization techniques on 1 million by 1 million matrix. So then classical optimization softwares simply may fail. There you may need to apply some high performance computing. So machine learning essentially is expansion of statistics to incorporate these concerns that classical method, so theoretically classical methods are still fine, except that they are not tractable. You have to incorporate some extra computational methods to incorporate for the size and volume of the data. So this is where the machine learning framework comes. So you have big data, you apply same classical statistical methods of linear algebra and calculus to come up with prediction rule, but to actually do the calculation you incorporate the high performance computation to come up with this final prediction rule. So this is what machine learning framework does. Now statistics, population data inference, get this in your head completely. So whatever is happening here from data to come up with prediction rule, you are applying linear algebra and calculus to come up with prediction rule, but that data itself is coming from a population and the inference is actually about this population. So in technical terms we will get into this, and bear with me for using some highly abstract terms now. There is unknown, so population, we remember we talked about unknown, so all possible measurements. So this is generally captured by something called a probability distribution, which we will come in next few talks to explain how probability distributions capture the population. You are doing some experiment, that is drawing data and doing some analysis on that data, come up with probability values. Just to, for that example we discussed, you have a coin with head probability, this P is unknown. The population is all possible tosses, but for whatever may be the head probability, for a particular toss it can be head or tail. It just there is certain intrinsic value as per as law of nature, that if you do it for large number of time, proportion of head will tend to be something stable. You want to predict that value P. This is where this, I mean, this is a very tailor-made small artificial situation, let us say. This is the scenario is can get far more complicated, but this actually gives you an indication what we do. So, you want to guess about this head probability. So, you do n tosses, and suppose the number of heads divided by n, you denote it by p hat. You take this p hat as a prediction for p. This is what essentially these are the things statistics does. You have made this experiment, you have calculated, this is your prediction for this. Now, how good this prediction is, whether one can improve or not, those are the concerns one can deal with later, but that is in an essence what statistics does. So, this is at the end of this class, I will ask you to keep this almost as a slogan in your mind. This is what statistics is doing. You have data, you want to come up with prediction rule, you will apply linear algebra and calculus. Thank you.